Hello, this is my third video on my build. Basically, what I'm going to do is show you my designs here that we looked at in the last video, and then use some instructions. I've worked out the instruction set to control the LCD screen, and a small program here that I've written that we can apply to these dip switches here in order to make the screen function the way we want to do it. And we will be sending a series of ASCII characters. You can see how these are built up. You would send the digits through. So if you wanted the letter A, you would send 0, 1, 0, 0, and then 0, 0, 0, 1 through, for example. So basically, I'm going to show you how using the code here, the fonts that can be sent to the display, the ASCII characters, the American Standard Code for Information Interchange, using a small sequence of binary code, how we can make this work. Now, the good news is that video number 4 will be the actual machine itself. It's taken me several weeks and a lot of troubleshooting to actually get it up and running. It works at the moment. It does everything and it codes, but at the moment I've got a real problem with the amount of letters that it generates when I hit the instruction switch. Basically, when I hit the switch, which sends through and says action this particular piece of code. If I send it the letter A, it sends either 1 or a string of A's to the screen at the moment. This is called, in electrical terms, bounce. So what I've done is I've sent up for a little chip. It only cost me about £1 something, for £1.30 or something. For about 10 of these chips. And once I get that in, what it will do is cut down the amount of noise that happens when I click this switch here for real. And basically, it will stop it from sending more than one character. So basically, that's the only flaw, and I'm waiting for that part to come. But apart from that, it fully functions. And I've learned quite a bit by doing it. It's a bit more complicated than the diagram over here when it comes to, I've had to add capacitors and more resistors to the circuit in order for it to perform correctly. So on to the actual coding part, which is the important part of this video. Basically, I will probably show and demonstrate this. It's a lot harder to do on the actual device, of how I'm going to use this to show how binary instructions can be sent through a computer system, in this case to a control chip on the actual LCD screen, which will then set off the screen to do what I want it to do. Now, you can imagine that these screens here were held in little typewriters and other devices before the advent of home computers, and used to use a keyboard to type in. And what you do is you type a letter on the keyboard and then it would appear on the screen in front. You could use shift keys and such to scroll the letters across or up and down. And this would be done by sending a set of codes to the screen in order to action that. So this is what this is going to demonstrate. Now, what has to be understood, though, and there's a bit of a recap on this board, we've got several devices here. We've got a potentiometer here, which brightens or dims the screen, so you can actually see the character, and that works for real as well. You have to do that. You've got a button here, which basically, when clicked, sends any binary that you have put in to these switches here. So you set this. This is the least significant bit here, so bit 0. Bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, which corresponds to the binary values 1, 2, 4, 8, 16, 32, 64, 1 to 8. So, for example, if I wanted to send the binary value 17, I would have to make sure that this is 1, 2, 4, 8, 16, I would switch that on, it would send 16. If I wanted 17, I'd switch this one on here and the one on, which would send 17 down to the screen. So that's what we're going to be using to actually plug in these characters. Now, the easy thing is, if I want to send it a letter A, first of all, I have to set the first set of dip switches to here. So I put 0, 1, 0, 0 here. And then corresponding to the letter A, I would put this one to 0, 0, 0, and 1, for example, and that would send to the screen the letter A. Okay then, so let's have a look then at how this works. So basically, I'm going to start the simulation. So it started off here, and I'm going to set in a sequence. Now, I've already written this here is the code. Here is the code that all the codes, and you can see I've got about 27 actual instructions, plus some instructions at the bottom, with a whole set of them here, which actually allow me to access the different parts of the memory on the screen, so I can put things on the bottom or the top row. I'll quickly demonstrate that at the end, but we're going to set a sequence of instructions in here to actually set up the screen. So like all devices, you can't just go and type letters into it. You've got to tell it what to do. You've got to tell it what to expect. And this is all set up in this little diagram here. This is the setup routine. This is a basic one. You can vary this using combinations of instructions depending on what you want. But basically, we're going to start off by putting the first command in. So this is the RS switch here. So it will be instructions, and basically, if you put it over there, it's for data. On here, it will write instructions. So basically, we're going to set the first one in here, which is it's a function set to 8-bit. So that means it takes all data lines 8 bits there. It's going to have 2 rows. So 2 rows of there are going to be used, and a font size 5 times 8. So let's go and put that number in there. So that's 0011. And then we want to press 1000. Now, once we've got that, we just click the switch there. Nothing appears to happen, so we then go to the next instruction, which is display on, cursor on, or cursor position on, cursor on. So we drop that down, so it's going to be 0, 0, 0, 0, and then set all these to 1. Okay, now you can see the screen lights up here, showing that it's actually obeying some of our instructions. And at this point, we can go up to the potentiometer here and show you that lighting up or lowering the screen brightness. So I'm going to lower it down just a bit so that we get the black squares in there. Now we want to, the entry mode set, we're going to increment the cursor position right when entering text. So every time we put text on there, the cursor position then moves to the right. Of course, you can start your text off at anywhere and move the text left or right, depending on what instructions. So we're going to set it up so it does that. So we're going to go 0, 0, 0, 0. So these are all zeros. And we're going to set this to 0, 1, 1, 0. So we do that, 0, 1, 1, 0. And we send that instruction to the actual screen. And lastly, we want to clear the screen here and set the cursor position to the right. So that is all zeros apart from the last one, which is set to 1. Okay, let's have a look and turn the potentiometer around. You can see the actual cursors flashing there. I'll just get it, so I'll flash it bright so you can see it. So we're all set up now. So now what we have to do is choose the instructions, and we'll come back to this table here to show you how this works. We're going to choose the instructions we want to send to the screen. So we want to send the letter A. So like I said, you would first of all switch it over to data. So if we look at the program here, we've got this RS here set to this side, which is 0. But when we want to send in characters, we have to set the RS here, the signal to data. So that's a 1 in that column. So now what we have to do is we have to use, to get the letter A, the actual number that we're sending is 64. That's the 60. So 1, 2, 4, 8, 16, 32, 64. And the actual letter A is 65. So we have to add a 1 to it, and that will be 65. So we're going to do that now. So we're going to set the 64 there, and we've got the 1 set there, and we can click on here, and we get the letter A. Now, if you know your binary counting, we would add 1 to that because we've got 1 and column 2. So we switch that off, put it to 2, and now we've got 64 plus 2, which is 66, and that will correspond to a B. Okay, just to see that on the chart here, we can see a B is 0, 1, 0, 0, 0, 0, 1, 0. Okay, so basically we have sent it a B. So now what we're going to do is carry on with the program and send it to C. So we just, C is obviously 67. So we've got 66 already. So we add 1 to it. And then we would click the button to send it to C. Right, all well and good. Now, when you press the space bar on your keyboard, this is actually what happens when you press keys on your keyboard. These codes are sent to your processor, and therefore they actually work like that. You can actually see it. So basically what you would do here is you would then send it the code for a space. Okay, and a space happens to be, I know already, the space happens to be the number 32. Okay, now 32 is along the third, so basically you would set up 32 in your screen by going, you turn the 64 off, you turn these two off here. Okay, and you would put in, we go 1, 2, 4, 8, 16, 32, click on that, and then click on the button there, and you get a space appeared there. Now, what happens when you press the shift key? We know that on a keyboard that if you are in a lowercase, you press the shift key, it goes to uppercase. Also, we toggle on the caps lock, and at the moment, this is operating like the caps lock is on. So if we turn off the caps lock, what it actually does is adds 32 to the value of any of these letters. Now remember, A was 65, so basically if you put 32 onto that, you get 97. So what you need to do, and if we go back to the program here, it's a very simple way to do it. And you'll see how simple it is in computer terms. If we first of all put it back to capital A, which if you remember was 64 plus 1, that's a capital A. If we want to add 32 to that in binary, we don't have to work out the number. We just have to switch on the 32 bit there. So remember 1, 2, 4, 8, 16, 32. So that's the difference there, uppercase, lowercase. Okay, so let's see that in our operation if we send that through. And then we get a lowercase a. Then all we have to do is exactly the same as we did before, switch that one off, switch that one off. That becomes then basically 98. So we've got 98 programmed into that. So that's 96 there. That's 64 plus 32 plus 2. And we then can click that and we should get a B. And then we add one more to it and we should get a C. Okay then, so we've typed some letters in there. Now we want to do something a little more. And here I can see that I've made a slight mistake on this, because we have to actually, I'll just rewrite this bit of code down here. We have to actually go back in and change the RS now to instruction mode, because we want to play around with those letters to actually manipulate them on this screen. So we have to go back up here to the RS switch and switch it back to 0. Okay, so from that, remember that was write an instruction, that's write data. So now what we're going to do is we're going to put a combination of switches here, and it should affect the way the screen is operated. Now this is all in this manual here, and I'm going to put this below the actual I'm going to put this below the actual video, so you're going to get a link to this. And these are all the possible instructions that you can send. And if we look at this here, we can shift and scroll all the letters right by putting in a combination. Now, these X's means that it's not really used, these two bits. You could just leave them at 0. So by putting from the least significant bit 0, 0, 1, 1, 1, what it actually does is this one moves either the cursor or the letters left or right. So this little flashing thing down the bottom here is the cursor, left or right. And by flicking a combination of these switches here, if you've got this one on here, it says scroll. If this is 0, it's move the cursor. If this one is on, it says right. If it's 0, then it's 1. So you can see that this one above it is scroll left, and all you would do is send 1, 1, 0, 0, 0, and on this one it's 1, 1, 1, 0, 0 to actually move left and right. So let's see that in action then. Go back to the code here, and we have, remember, scrolling right. We can put in that combination here. So we'll start off from the least significant bit here because it's easier. So that's 0, 0, these two set to 0, 0, and then we're going to set it to 1 here, 1 there, and 1 there. So that's the combination needed to shift the actual screen right. So we're going to do that and click that. And you can see that it's moving it. Now we said 3, I've put 3 of the same commands down here. So we'll click this 3 times and you see we can scroll it there. Now all we have to do to scroll it left is we just need to actually set another digit in. In fact, I've done that slightly wrong there. Again, attention to detail. Okay, what I have to do is to scroll it left, I have to turn this bit off, the cheat a bit here. I'm just going to copy these across and do that. See, I'm even debugging as we go along. Okay, so basically what we need to do, and I'm just going to do that here, is we need this combination here. So all we have to do is switch this one off here. So that's left, that's right. So left and right. So now it should go back again. Okay. Now, basically, so just by doing this on here, you can send it right or left. Now, say I want to overwrite a letter here and put a different letter here, I can then basically move the cursor. If we go to these instructions here, you can see if I want to move the cursor left, we do the same combination as, remember, we wanted to move this left. We just turn this bit off here. So we go 1, 0, 0, 0, 0 instead. So 1, 0, 0, 0 will just move the cursor left. You can see that's moving it left. So I can then change that letter or do whatever I like. So I can move it all the way to the left here. And then if I want to move it right, remember that's 1. That changes it from scroll to cursor, and that one's left to right. So I can just change that one. And again, I can move that to the right. So you can play about all you want with all these different functions. Now, there are a lot more functions than that on here. So I'll just go through this chart to tell you what they are. We can set the cursor back to the home position by putting in this command here. So basically, if I set this to, and if we go here, it's 000000010 here, like that, 000000010. What it should do when I click that is move everything back to what it was at the start. So it's like a reset and puts everything back into that position. If I want to clear all the text in the screen, I can just put in, I'm not going to do this, but I would put like that, because I don't want to have to type it all back in again, but I would put all zeros apart from one at the clear screen, like we did when we set up the screen at the start. But interesting, what I can do is if I want to write in the background and I don't want somebody to see me typing all these words in, I can, for example, turn the display off by putting in all zeros here, and then a 1 followed by 3 zeros. So all zeros, a 1 followed by 3 zeros. And what that does is turn the display off. Now, the digits are still there in memory, it just turns it off. So what it allows you to do is you could put in a combination of binary code in here in the background, and then when you want to switch the display back on again, yeah, basically, all you would do was look for display on, and you would just put this number in. So you'd put that one, that's display off, display on, and you get the display off. So I could turn the display off and the display on. So it's very, very simple to control this. So you could mask completely what you're typing and then present somebody with the whole words instead of it writing out like a teleprinter. There's obviously loads of different commands down here. You can scroll the text left or right. So if I just put in a combination of switches here to scroll it to the center, I can show you what would happen if I want to scroll something here. Let's put this in here and move it across. 2 seconds. I'm going to go back in and we're going to go to scroll right 00001. Let's go back to here. There we go. We're moving it across there. Now I'm going to set the cursor position over here to that position here. So I'm going to go for cursor left. So I'm going to set the mode. So remember, we said that that's moving it. We're going to set the cursor to move, and we're going to get it to move left. So basically, I'm going to scroll the cursor. Now, we've actually, can you not see? The cursor is not there. You can't see the cursor. So we've actually not switched it on. So we have to send a command to say, can I have the cursor back on over here? So we've got all these, we set the cursor off and we can put cursor on, but I'm just going to send it a command to switch everything back on the screen here, not just one thing, but it all on. And we should, and you see the cursor is dropped down to the bottom here. So I'm just going to move, I'm going to shift it, I'm going to shift the cursor right a bit, okay? So remember that shift, or sorry, beg your pardon, that's move, shift, or cursor. So I'm going to go to move cursor and right. So I'm just going to put that there, and then that will start to write things to the right of my cursor. Now I'm going to move the cursor right a few steps because I'm going to show you something which happens. It overwrites a part of the memory. So I'm going to go across here and I'm going to put it where the C is here. Now what I'm going to do is I'm going to change the mode of the screen. So actually what it does is it shifts the display to the left. So increment cursor position left when entering text. So instead of moving it that way, every time I type in text, the cursor moves that way, it's going to move to the left. So I'm going to type something in new here, maybe a D, and then I'm going to go there and put in a C, and then a B, and then an A. So I'm going to go, or no, I'm just going to do D, C, B there. Okay then, so it's sitting there, and I need to put that combination in. So it's 001 at this end. So 001, and that should be it. So 0, 0, 1, and if I press enter now I'm going to switch it over back to the RS to write mode, and then I'm going to put in the capital D in there. So we need a 64, and we know that that is A, that one is B, C is those two on, so D is going to be this one on here. So that should be the letter D. And you can see it replaced with D, but instead of going right now, the cursor's moved to the left. So we drop it down by 1. So we need those two on there. So that is a C. And we're going to drop that down by 1 again. And that becomes a B. So BCD is written into there. So that just shows you, by mucking about with this table here, we can actually now control very much what goes on the screen. You can control everything. Okay, so that is basically it. So if we want to reset that instruction so that we are actually shifting right again, we enter set mode shift left when entering text. Okay, and we want enter text mode increment cursor right when entering text. That's the one we want. So we need to go to put this to 0 and these two to 1. Just make sure everything's 0 apart from those two, which should correspond to 0, 1, 1, 1. So we click that in instruction mode. We've got that, and then the characters should start writing the right way again. Right, now what we need to do now is we need to talk about the difficulty of LCD screen. For us to be able to use the second row, it's not a trivial matter because of the fact, here's some more code. The red ones here I seldom use, and they'll take a little more there. But what we have to do is a special setup command to move a row. So we need to turn, it says here, a setup command where everything is set to 1. The RS is set to 1, which is to write an instruction. Everything's set to 1 here, except the least significant bit, which is that one here. And we send that instruction through. Now, the next thing we need to do is we need to look at this. If we send an instruction in here, if we want something to set the cursor to the top left position, we would put 1, 0, 0, 0, and the rest of them 1. So basically, apart from that, we'd have to put everything there, and that would send the position to the cursor position to the start of the letters. Now, we remember we did this. Now, what I'm going to do is I'm going to scroll. But if I wanted to drop it to the next line, we would have to set in the 128 and the 64 bit there, and that would then drop it to the next row. Now you can jump to any one of these squares. Now remember, what I've done is scrolled this screen across. So this really is the start of the screen here. I'd have to scroll all the way along there. So it thinks that this is the start of the screen and the rest of this is in memory. Remember, we scrolled the display across. So if I wanted to go to position 2 there, I would need to add 1 to this equation. So we've got these two set, and we're just going to add 1 to it, and it would set the cursor to the next position. So if I wanted to put it over here, so that is 1, 2, 3, and 4, I would have to put 1, 2, and 4 on there. So that is 4 on this side. And basically it would jump to there. So you can jump to anywhere you wanted. And also, if I wanted to go to that position on the top row, I would just flick that over. That's bottom and top row there, and it should jump up to that position there. So you can literally control where the cursor goes anywhere on the screen in order to do that. So remember, you've got to set up a move here before you do it. Okay then, so I'm just going to reposition the cursor. Remember that I'm going to reposition it over to the right-hand side of the screen. Remember, we did that before. Here we go. So this can return to home, and we click on there. And it puts it all over there. So that should give you a context now. So we're going to set up the screen again, and we're going to show you how to move the cursor across to this side here, the edge of the screen. So first of all, we have to switch all these on, set up a memory, right straight to memory position. So we set everything up there like we did here. So we set all these there, and we click that. And then we're going to move now to the bottom row, and that's going to be the bottom row 0. So that's just going to be this command here, just a normal bottom row setup, which is the 2 most significant bits on. And then we've got to count across to see how many. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15. So we know that's 1, 2, 4, 8, 16. So we want to, that's one less than that. So we want to switch all of these on, and they all add, that's 8 and a 4 and a 2 and a 1, which add up to 15. So if we click on that, it sets the cursor straight to the position here. So that's 0 to 15. And that is a 16 long screen counting 0. And if we want to go up to this 16th one there, we can then just switch off that switch there, and it goes up to that one. And that will allow us then to write in a letter there. So I'm going to put it back to address mode here, and I'll write the letter H. And I know the ASCII for H, it's on here. So we can go down to H, and it's just 0100, and H is 100 at the end. So I'm just going to write that into here. So we're on write mode. So it's 0100 and then 1000. So we click that there, put the letter H. Then I'm going to write to the screen again here. And I'm going to put an H below it. So I'm going to turn all these back on to go for a screen write again. Remember, I've set the RS, sorry, that one, the RS to write an instruction, click it on there, and then I'm going to drop all these down here. And remember, what we did was we set that to 15 and that to write on the bottom row, those two there. So basically, you click on that there, cursor goes there, we set it to write mode, and we can then reset it to another letter H, okay? And that's how you do it. So it's as simple as that. Now you can play around. If I wrote a sequence of instructions and program to run these one after the other instead of me clicking here. So imagine that I set a load of switches down here and set them a program, and every, let's say, quarter of a second, they move from one to the other. You would have a computer program that could write letters on the screen, scroll them left and right, and do all the things that you would do on a typewriter. Now, why have I done this? Because my next project, after I've completed this build, will to build a retro computer a la 1980s, and I'm going to use a Z80 CPU, some static memory, a read-writable ROM, okay, an EEPROM as they call it, and a clock circuit. And what I'm going to do is I'm going to attempt to, by using a number of dip switches or a rudimentary hexadecimal keyboard thing, so I'm going to use 4 bits and send a combination of hexadecimal numbers, and I'm going to write machine code programs to do this, but using a computer, basically. I'm going to build a 1980s computer to control this screen like you would on a calculator or a typewriter. So that should take me several weeks. I've got to source all the bits for that, but I've still got to finish off this project, which I'll show in the 4th video. So I hope you enjoyed that and it's informative. I'll put some of the program and some of the notes onto these here, onto the video at the bottom. And I hope you enjoy it. And if you want to build it, The actual build itself was a lot more complicated than this, but this is the essence of it. When you actually play around with real electronics, you have to balance all the lows and highs out and make sure that the right amount of charge goes to each part. So I've employed a chip or two to make sure that the right amount of electricity is sent, because these are all mechanical switches, and mechanical switches don't switch on as cleanly as they do on the software. So for instance, that's got a little spring in it of mine, and you hit it, and although you press it once, the machine thinks that it's being pressed on the way down and on the way up several times. So you get, instead of one letter A, you get several. And there's a little chip, a schmitt trigger, which evens out what is called bounce. So it doesn't allow any more entries until the switch has been timed to be up and down, basically. So that's the last bit I have to do with my project. Okay, hope you enjoyed that video. Thank you for watching.